Hi, Year 9. We're going to continue with 1D, rational numbers and irrational numbers. So we want to know the difference. We spoke about integers on the first day. Then we talked about decimals. Now, when you have decimals, what does that really mean? What kind of number are we dealing with? So you have something called a rational number, and you have something called an irrational number. And together, you guys have a bunch of numbers that really make up the real number system. So every number that we deal with on a daily basis is a type of real number. And we just made this kind of visual over to the right and just out of boxes, so we could see how they all fit into each other. They're like the little Russian dolls, right? You have one type of number, but it could also be all these other numbers that are different and bigger than that. So real numbers is the big, huge box around the outside. Once you have a real number, so a real number could be anything. It could be a whole number, it could be a negative number, it could be 0, it could be a decimal, it could also be a fraction, or it could be a square root. Okay? So any type of number that we talk about on a daily basis, it's some kind of real number. But if we want to be more specific, it could either be something called an irrational number or a rational number. So if you've ever been told that you're acting irrationally, all right, we can't always guess what you're going to do next. That is sort of an irrational number. So for example, you might put into your calculator the square root of 7. Okay? If you put into your calculator the square root of 7, you're going to wind up getting a decimal. So 2.645755. So these numbers have no pattern. We don't really know what's going to come next unless we check the calculator. And this is a decimal that is non-terminating. So it does not, this part of the number, the decimal part, does not stop. So it does not terminate. And there is no pattern. Okay, so there's no repetition. I can't guess what's going to come next. So irrational numbers are the ones that we can't really guess what's going to happen, and they don't stop, so they just keep going on with nonsense. Whereas rational numbers, we can turn them into a decimal, and we can turn them into a fraction as well, and the decimal would wind up stopping, or it would wind up repeating. So if you think of the number 1/2, if I turn 1/2 into a decimal, I'll get 0.5. So that does terminate, it does stop. Whereas you could also think of the number 1/3. So 1/3, you're going to get 0.333, and that 3 is going to keep repeating. So even though it doesn't terminate, there is a pattern, and I know exactly what's going to come next. So if you're dealing with a rational number, it's a number that I can actually make into a fraction. So I can always make it look like something over something else. So A divided by B, right? If A was an integer and B was an integer, I could make them into a fraction. So I can always make them into a fraction if it's rational. If I get even more specific, I could take away all the decimals and I could just deal with integers. So since integers do terminate and they do have a pattern, there's really nothing after the decimal, right? Integers are considered a rational number as well. They're kind of a subgroup of the rational numbers, which is why they're in a different box. So they are whole numbers, positive and negative, including 0. And if you take away the negatives and you get down to the numbers that you probably first learned when you were in kindergarten, right? We're dealing with counting numbers. So counting numbers start at 1, 2, 3, and they go all the way up. But you didn't know what 0 was yet, and you didn't know what negative numbers were yet when you were really little. So you just started with counting 1 block, 2 blocks, 3 blocks, and then you kept going. Okay? So counting numbers are a subgroup of integers, which are a subgroup of rational, which are a subgroup of real. So they all fit into each other. So for example, if you look at the numbers on the left here, if you look at the square root of 3, okay, if I take the square root of 3 and I put it into my calculator, I will get 1.7320 ... Okay, I'm starting to notice that every square root that's not a perfect square, I'm getting these crazy decimals that have no repetition and they never stop. So again, that would wind up being an irrational number. I could put it over here. Square root of 3, okay? 1 1/2. If I change 1 1/2 to a decimal, I'm looking at 1.5. Well, 1.5 does terminate. Even though it's a decimal, I can turn it into a fraction, as you can see here. Could also be 3/2, okay? So that is a rational number. Think for a moment where you would put -3/4. Since it's negative, I know I'm looking somewhere over here in the rational numbers or integers. Counting numbers cannot be negative. But since it's a fraction, it's not a whole number, 3/4, it's going to wind up being a rational number. If you look at it as a decimal, 3 divided by 4, so -3 divided by 4, if you did that in your calculator, you wind up with -0.75, right? So if I do that again, I'm still looking at a rational number. And last but not least, 10.044. So it's a positive number, but it's also a decimal. So again, I'm looking at rational. So first, before we do any operations with decimals, we have to identify what type of number they are and make sure that we're comfortable identifying them and using this language. I know these aren't words we use on an everyday basis, but we should start so that we feel really confident and comfortable using them when we speak to each other in class. So once we have a little bit of vocabulary, we can take a look at how we actually work with the decimals. So this is just a couple examples of what you guys are going to be doing in class next time. One example would be writing a decimal for 3 3/4. So I know I have 3 as my whole number, and then I have on top of that 3/4. In order for me to turn 3/4 into a decimal, what I have to be thinking is 3 divided by 4. And that is my fraction, okay? So 3 is my whole number, 3 divided by 4 is my fraction, which turns into, so my 3 is my whole number, would be 3 point something. My fraction, 3 divided by 4, is 0.75. And if I wind up taking those and adding them together, since I have 3 and 3/4, I don't want just one of them, I'm going to wind up with 3.75. Now, I know that you guys know that 3/4 is 0.75 without having to go through that. However, it's not always going to be 3/4, right? So you want to be thinking of that same process, no matter what the fraction is, no matter how hard it gets. You know how to do it basic. You know how to divide the top by the bottom, turn it into a turn it into a decimal, okay? And then write them together. So they're one number added together. Now, if I go backwards, 2.385, all right? That's not one that off the top of my head I know exactly what fraction that is or what decimal it is. So I'm going to wind up looking at 2.385, and I'm going to say again, okay, I know that 2 is my whole number. 385 really means, so 0.385 really means 385 thousandths. Remember, this is your tenths, hundredths, thousandths. So what I'm really going to be saying is 385 thousandths. Okay? Again, I don't want them separate. I want these to add together. So I've now looked at this as a fraction, 2, and I want to add it to 385 thousandths. In this particular question, they said to leave your answer as a fraction, whereas the last one they said to write your answer as a decimal. So I'm actually going to write this down as 2 wholes, and then 385 divided by 1,000. Now, I'm pretty much correct at this point, but I'm not simplified. So remember, you guys were asked to find an equivalent fraction last year and the year before so that you could always leave your answers in simplest form. So when I look over here, I notice that the last number is a 5, and I notice that this last number is a 0. So I'm thinking that I can probably divide by 5 to simplify this fraction. So let's go ahead and try. Let's try to divide by 5 and see if we can get a little simpler number. Go ahead and pause here and try to simplify it down and see if we get the same answer in the end. So 2 wholes and 77 over 200 does simplify down. So these are still both equivalent to 2.385. Equivalent just meaning these are the same fractions. They're just represented differently because we have a simpler version. So we always want to try to simplify our answers as much as possible. So what we just did was we simplified. And we did that by finding, right, your highest common factor. Remember, that's going to come in here as well. Find your HCF. Okay, bringing back all these wonderful reminders from last year. Last but not least, guys, decide which is larger. Okay, so 7 divided by 12, which you might also see written vertically, or 8 divided by 15. Which one of those is actually bigger? And it's really hard to compare when your denominators are not the same. So right now we're talking about 12ths and we're talking about 15ths. So I can either try to change them to have the same denominator, or I can convert them into decimals, and that way I can compare them a lot easier. So let's go ahead and divide 7 divided by 12 and get a decimal. And also divide 8 by 15 in order to get a decimal. Go ahead and do that, and then see which one you think is actually bigger. So when I did this, I got 0.58333 repeating for 7 divided by 12, and 0.5333 repeating for 8 divided by 12. So if I put those next to each other, 0.5833 and 0.5333 repeating. Notice that in the hundredths position, we have an 8 and we have a 3. So which one is larger? That first one, which was 7 divided by 12. So 7 12ths is larger. Okay? But first you must convert them to be a decimal so that you can compare them correctly. Unless they have the same denominator already, then you could just compare the numerators. All right. Remember, guys, always go back and revise your notes. See what you need to ask me about next class. And go back and make sure you finished everything from class today. Have a good night. I'll see you soon.